has capability to detect anti-forensics. This has capability to detect anti-reverse engineering, because the CSR/CS.exe, when we actually passed it on to reverse engineers, even their static and dynamic analysis couldn't actually just this was having a capability to detect a tool and it will die automatically.
The CSR/CS.exe, most of the antivirus solutions, they rate it as a very low impact risk.
Correct.
It is a Nazi-like thing, isn't it?
Yes.
And it's apart from doing this, using this ICMP.dll engine and using the pings.
Right.
It has not been established that it is doing anything harm.
Correct.
The only thing what it does is, it is, you can say, a pre-attack probe.
Yes, this particular there was no damage. Correct.
It has not been found to be very, risky.
It has a very less stress, but being present.
Even some antiviruses, they just pass it on, they don't remove it.
But actually, in connection with this particular use, we found a lot of 2 or 3 different processes which actually were involved using this CSR/CS also.
Actually, we had analyzed this. I am from National Informatics Center. So we have also 50,000-60,000 clients. So we found this sort of activity on the number of clients. Then, because it is very difficult to remove it from all the client samples, so what we did, we uploaded this to some antivirus solution just to get their pattern updated.
No, normally, even in our case, what we did was to contain this. Actually, we created an extra tag and patched it to that location. So that this will not.
Ultimately, we just had to create some of the antivirus solution. They said, "Oh, absolutely, this is nothing wrong with this."
Yes, exactly.
Creating a patch file.
Patch file
because it was having that SHS attributes, we just cleaned the attributes and then removed it like that. It happened.
Okay.
As it has fooled the PID and even those exceptions, it seems it has exposed the kernel space.
Yes, actually.
Is this related to CSR/CS? I don't think so.
This one?
This one?
No, not actually. This PID, this socket is only with CSR/CS. This was the actually botnet of connectivity. That's what. This was not related to CSR/CS.
Yeah.
But there are through CSR/CS. CSR/CS was the entry point for us to start the analysis.
Because we analyzed in the sense that we had one machine which was doing this probe space, and then we also sent it to the traffic at the end of it just to see what all this is, what all it can do.
Right.
So for our required, over a period of 2 or 3 days, we did not find it doing anything harmful like
that is
creating any TCP connection outside.
Pardon?
It did not create any TCP connection.
No, like it creates. Actually, this particular, I'll tell you. Actually, when we analyzed the CSR/CS, actually it has a pattern of getting infected. Or this particular exe comes from an email, actually, and it's kind of a spear phishing which was happened on that particular machine. And then the entry point for this was that, and as well as there were a couple of backdoors later on which were introduced after this particular exe was there. Actually, what this exe they used exactly what they used this is to know the subnet. This particular exe they only used to know the subnet. And actually, how we find it out is because there were unused IPs. And so it landed up in the sinkhole. If it is a valid IP, it won't be even recognized.
Many times like we download the trial version and then uninstall it. So that it ends up put some kind of .exe and then this kind of thing using for a legitimate purpose only. It's not harming our business. That's why like none of that antivirus is detecting this.
Correct. The activity, if you can see here, there is nothing wrong.
As you think, it gives a random, generate a random page.
Correct.
So how come it's generating? Because when the system is on, so that time some legitimate process also might get initiated, and that particular process will have maybe kind of some conflict kind of thing may arise. So how come it's possible? Like maybe like there's a through the randomization, the same PID it will generate with that other authenticate process will also have the same PID. So how come it's taking care of it? Maybe like let us say this PID is 2492. So through the randomization, it has also generated the same PID.
Okay.
Is it
So
possible?
yeah,
Is it possible? I'm just asking.
No.
How come he's taking some different this thing range altogether of
Yeah, actually means when this particular process is loaded, it will be having a process ID given by them. So obviously, like this 4988 is the process ID from the machine where it is running, and this particular PID is nothing but an activity by a suspicious account or suspicious process to hide or to actually like confuse the operators.
It's going to come to the processor itself.
It will get, yeah,
Because the processor will recognize
Yes.
the PID only.
exactly.
Yeah, but this kind of obfuscation can be dangerous for the it can actually kill the stealth. Because some kind of an obfuscation which can affect the processor activity itself. So you kill the stealth and the payload, right? Stealth part, then the whole processor doing obfuscation is getting negative. The idea is to obfuscation is not to get caught. And but I don't know what the programmer would have had some logic in his mind.
If it
So I
has
don't know.
across the kernel space, then it's really hard. It's like almost hide the kernel routing. If even throws, like for example, you can handle kernel throws if you put on kernel DB. Similarly, if it has encroached the kernel space, all the data structures and kernel records, it won't be that impossible.
Let's actually move ahead and talk to you. Actually, let's move to a particular interesting area of Windows memories, virtual address descriptor. And what this virtual address descriptor does is actually every processes are stored in a battery kind of area. I'll just grow this particular image you get. This describes the memory ranges of any memory range of a process into a Windows system. And what this does is this allows processes virtual address space to be reconstructed. So when you create a battery or when you walk down virtual address descriptors, you will come to know a lot of relations and file address. Interesting, actually, information can be like registry keys and can be it can actually like map to a particular file from the file object. So if you create a battery, it will give you a lot of information and draw a connection between the processes and the number of files which are being used by the process. So this is the area, the dotted line if you see. If this process is exited from the execution phase, the dotted lines means the connection between var node, object table and file object will disappear. But still, this connection of control area pointing to a file name, a page table and the segment object, that is the file size, which is an important actually factor. This still remains though. So persistence of data in a volatile memory actually remains through these connections. So actually, if we reconstruct it, it might look like this. So you will have the base processes and the connection between the processes and what are memory locations which a process can actually have. So this is a very valuable information here to construct a battery. Actually, I have a couple of more interesting videos for you, but if time permits, I'll just get back to you on this. I have actually a couple of videos where you can create or you'll find out locations where the SAM file is and from the RAM where you can find the passwords. If time permits, I'll get back here. And the SSDT is actually the detailed analysis of using Python and volatility framework. I have a video of this also. Okay, if time permits, we'll get back here. One interesting point which I actually was interested in is anti-forensic attack. Actually, anti-forensic attack is nothing but people, what they will do is they will try to frustrate analysis. They will try to remove or tamper the evidence or tamper their own, clearing their own footprints so that they go undetected. So one type of this anti-forensics which I am going to discuss is direct kernel object manipulation. I'll just take a very small example from Shetzer again. Actually what this, we already know this image, right? Now this particular process is using DKO. Means what? It doesn't have an FLIC and unique ID. So process enumerations will, or a forensic methodology of doing process enumeration cannot detect this. So it's an kind of anti-forensic technique which can be used. And this particular process was handling this. Excuse me. And what you can do is to actually we should be better than them, right? So what you can do is we can have, instead of doing process enumeration from the link IDs, you can do it from page frame numbers. You still have the page frame numbers or PFN database altogether available to you. Map it and create actually like the forward links, and the link page frames have a connection. So you can draw again a connection from the PFN database. You can draw a connection and you can find this particular DKO or the bypass, you can say, process also can be detected. As well as PT is nothing but page table entry, and page table entry has a connection that points to the number of pages. It's a virtual address, and still enumerating and verifying that. I'll just take one more image so it will be clear actually. Like see this particular example. Okay, this is the PFN number 0025687, and what it has is it has an PT address of C030C00. And now the interesting part is the verification part. What you can do is the containing page entry should have the PFN number. So you can say 025687 is reflecting here. So this verification, if you do for a process, can actually detect a DKO also. Means if any process which is hiding because of direct kernel manipulation attack can be still found doing this kind of verification. As I was talking about, like when we do open files, when we do registry analysis, when we do analysis, and we come across many files which are unknown origin. Why I am saying unknown origin is we don't know where this particular file has come to us, or whether this particular file is what, doing what, we don't know yet. So this particular area, how to start with is one part of research, where what you can do is whether or not you can identify it's a binary, what kind of binary it is, and then you can load it to a particular analysis phase, wherein you, from the memory dump, you can actually carve a file out. And this particular file, you can load it and do a static and dynamic analysis for the behavior. That is what actually we did. CSRCS obviously was the one, as well as there were 4 more different files which was of unknown origin to us, and we don't know yet, that time at least, what those files were, and then we actually try to do a static and dynamic analysis. Static analysis is basically nothing but load a file, put it into a kind of deassembler or debugger, and follow line by line pattern. As well as dynamic analysis can load this file in a running environment and then it will try to create or it will execute line by line and can show you kind of activity which it can do or the capabilities which this binary has.